Hi, I would like to show you how I created the simulated DAQ in LabVIEW as well as with the real physical device. Now, first of all, let me show you that I've actually pre-created a block diagram and a front panel showing the DAQ system which reads from the AI channel 0. Right, so I would call it channel 0. Right, now before this, allow me to show you on the NI-MAX. Now this is my NI-MAX, as you can see. Now currently I only have the USB 6009 device 1. Now this device 1, as you know, it is the simulated DAQ which I have created earlier, and I have also shown you how to do that in my earlier video. Now currently what you see that I have a NI USB 6009 device number 2, which is marked as a cross. As you can see, there's a red cross that is indicated there because I have not connected the physical device. Right, so what I'm going to do is that I'm going to use the physical USB cable and connect this into my computer, which you are not able to see it on your end because I'm only showing you the PC screen. So I'm going to use my hand to pick up the USB connector and connect into the USB port. So in a short moment, you will see that something will appear and show on the NI-MAX. So I've just connected. Now once I've connected the USB connector, which is attached to the device, this configuration window will be popped up. Now I will just, for the time being, do a close of this panel. But what I want to show you here, now as soon as I've connected the USB hardware, you will notice that the device 2 becomes real now. And the red color arrow, the red colored cross is now changed into the black color USB logo or symbol, which means that the device is now connected and the device is number 2. Now what I have here is also that the temperature sensor TMP36 is connected to the AI channel 0. So you are not able to do this at home or outside of the lab because you do not have this device connected to you, but it's good to show you how do we do it when you are back in the lab and with your temperature sensor such as the LM335. Now once the hardware is connected, always do a self-test to ensure that the test has been successful, which you can see over here. Now I'm good to go. I'm going to close this, I'm going to minimize the USB, the NI-MAX, and I'm going to show you on my block diagram. Now very simply, what I have here is a simple while loop with a wait millisecond delay of 100 milliseconds. I have a stop button, as you can see. Now because I'm reading from voltage from the temperature sensor TMP36, right, and we know that the output of the sensor is in voltage, I will need to do a simple conversion to convert that voltage into temperature in degrees Celsius. Now how am I supposed to do that? You notice that I've actually taken the output of the temperature sensor and multiply it by 100, and I take the resulting answer and subtract by 50 to get the actual temperature in degrees Celsius. Now how did I came about doing this expression here? Now let's go back to take a look at what we said earlier about the equation. Now technically we are looking at the last equation over here, where we want to find what is the y in degrees Celsius, which is equals to 1 over 10 times the output of the voltage in millivolt. So what happened is that you can see that the initial output voltage from the temperature sensor is in volts. So by multiplying 1000, but at the same time, I also notice that there is a 1 divided by 10, which means that I'm taking 1 over 10 times 1000, which is the same as multiplying by a factor of 100, right? So by doing so, and the resultant of the multiplication answer, I would have to minus by 50 to give me the final answer of y in degrees Celsius. So this is what I've done. So let's take a look at the demo on LabVIEW. Switching you back to LabVIEW. Now, you will notice that on LabVIEW, I have over here, let's do a tile left and right. You can see that I've actually created a device name, as you can see. Now, this device name is something very unique because I'm able to connect, as you can see over here, 2 different devices now. Let me zoom in for you. Now, when I choose the device name, I'm able to choose device 1, which is the simulated device, or device 2, which is the physical real device. So now allow me to choose first the device number 1, which is the simulated device. Now let's take a look and see what's going on here. Let's click the run. Now I may not be able to see anything very interesting over here because the temperature from the TMP sensor 36 is actually a simulation for the device number 1. So technically I will not be able to see any physical reading, but except that the fact that the program still allow you to still continue executing and not prompting an error or something like that. Now, so let me click the stop button, and now I'm going to switch this to device number 2. Alright, so I've switched to device number 2, and let's see what happens when I click the run button. Now when I click the run button, now observe that I'm actually seeing something over here. Now apparently, okay, let me just move it over to this side. Now the temperature is about, currently in what I'm seeing is about 30 degrees. Right? So I'm going to try to put my hand onto the temperature sensor and perhaps bringing the sensor to a warm surface, such as a warm cup with some warm water inside this cup. You will see that the temperature actually rises quite rapidly. Now the temperature has gone up to about 35-36 degrees Celsius. Now as soon as I release that hot surface, I would imagine that the temperature would tend to come down fairly quickly in a short while. Now this is a good way to test your USB device, right? Even though you may not have the physical device with you, you still can at least carry out doing the testing. If I stop now the program, I can still proceed to test the device 1 of the USB 6009, but this is a simulated DAQ. Now you cannot expect to see any real temperature reading in this sense, but nevertheless it still allows you to run your program without any prompting you of any error as such. Now with that, I will just stop the video for now.